All right, everybody, welcome on in. So I usually try to have the stream and the Zoom meeting open at about 5 minutes prior to class. I was dealing with some administrative issues for the class right beforehand. They were trying to get someone added into the class. So I was a couple minutes late getting the YouTube stream up, but it looks like people are beginning to file in at this point. So that's great and wonderful. People are already putting their names up. That's going to make it that much easier when I take roll in a few minutes. So great. Thanks for taking care of all of that. That's fantastic. So we'll get to all of that. Forgive me if I seem a little bit discombobulated. I'm switching over from that administrative issue where we're trying to get a student added and figure out if there was a way to do that, get that student added. So I'm sort of having to recollect my thoughts here. But I know what I'm supposed to go over. It's just going to take me a couple minutes for my brain to kind of transition over from one to the other. Two things I want to make sure of that everyone understands. I usually have to say these a few times because some students, you miss it the first day or you forget or whatever. It takes a little while to get used to the new class. Is that I just want to remind you that we meet in this class for a very limited number of hours. So you definitely want to be in the practice of recognizing that, you almost should think of our class meetings as the supplement. Some people kind of think of it as like the class meetings, we come in, and then they're supplemented with the videos that are on Canvas. It's almost the other way around. Think of this as the supplementation to the videos that I'm posting on Canvas. And I'm going through, I got a few more chapters all finished off today. Hopefully by next week I'll have everything totally up for the whole semester, and I'm certainly ahead of where everyone needs to be. So the sections that you need are up and going. But I'll have the rest of the stuff up in another week or so here for the remainder of the semester. But make sure you're watching those videos. There is no way that I can even come close to covering all of the material in class time. So again, that comment that I hear regularly, or not regularly, but you hear it from students here and there, which is you never talked about this thing in class, right? I'm telling you right now in this online course, there is not time for me to talk about everything. So I talk about the things that I think are most important or the things that students struggle with the most. So sometimes there might be a topic that isn't necessarily like the most important topic, but it's one that I know students have a lot of trouble with. For instance, when we get to absolute value stuff, absolute value doesn't come up a tremendous amount in this class, except when it does, but students get very confused when it does come up. So when we get to that portion, even though it's a smaller section, I'm going to go over it because I know that students really struggle with that section. So as the professor, I'm picking and choosing the topics that I think you need my discussion from the most, but there are other topics where you're going to have to fill it in with examples from the book, the videos that are inside of Canvas, the videos that are in the homework problems, and possibly maybe even videos that you find elsewhere on YouTube, but then also relying on each other. Okay, so remember I've got the first couple of discussions here are about meeting each other in this class and then trying to make some kind of connections that form some kind of a study group. And you can decide what that means for a study group. Some people take it very seriously. They have very scheduled meetings and they get together and they work together. That's great. That tends to people who do that tend to get A's in the class because they know the material inside and out. If that doesn't work for you, you could have more of an informal situation where maybe you can text someone or you can email someone else when you're having questions, all right? And I would like to also point out there is tutoring. The school provides tutoring, okay? You don't have to pay for it. You've already paid for it with your taxes that fund the school and with your tuition. Those tutors are paid for. It doesn't cost you anything. And from what I'm hearing right now, those tutors are essentially being unused because there's so few people going on campus. You can, I believe they change the rules every semester. It's been kind of a weird world for the last few years, but my understanding is you can still Zoom in with them and you can set up a Zoom appointment to get help with some of your homework. And also you can go in there, I believe, and you can get help. So if you're comfortable, I know it's an online class and some people took it because they don't want to go to campus, but I just want to make you aware that is a resource that is available to you, and right now it seems better than ever. Years ago, people, I would have students to say, yeah, I went to the tutoring center and I had to wait 40 minutes to get my question answered. My understanding is I have students reporting that if they go into the tutoring center now, you basically get a private tutor. Is kind of what's happening because you're the only one in there. Like there's hardly anyone showing up to tutoring, which means you get all the attention from the tutor that's in there. So, and this is a class that the tutors are going to know inside and out. There's a couple classes where sometimes the tutors haven't taken that class, like the topics class that with the Math 40 that we have, the topics class, sometimes they haven't taken that class. They haven't always taken statistics. But this college algebra is a class that they definitely will know how to do all of the stuff that we're going over. They will be very, very, very good at helping you do that. So that's probably one of the best things you can do, right? I mean, come to the class meetings, watch the videos. If you're still confused, by all means, get yourself that help from the tutor. That can make a huge difference for students. I've seen students go from being completely lost to A students, and the only thing they changed was making use of that tutoring center on a regular basis. Okay, so that's highly encouraged. The other thing I just want to point out, because I know everyone's kind of getting used to it, some of you may not have even been here last time or for the whole time because you're confused. Remember, there's the YouTube stream and the Zoom meeting. You are welcome to be in whichever one you want, but the YouTube stream is going to have more visuals. If you're in the Zoom meeting, all you're going to see is the green screen behind me, the green wall, it's the green screen. If you're on YouTube, you'll actually see that green screen replaced with the visuals that I'm trying to show you. And then remember that that video gets placed into a playlist so that you can just, like if you miss a class or even better, if you were in class but you were like, oh yeah, he talked about this, but I kind of don't remember what he was saying, and you want to watch me have that discussion again, just go find that video on YouTube and find the right part where I'm talking about what you're interested in, and then you can watch that. So you can make use of those videos along the way. Okay, so I'd say those are two big things. Just keep that in mind, that's kind of how everything works, right? Let's see. Interesting. Okay, so with that said, so we're getting into the material here. Again, I'm not going to have time to cover everything. I'm going to go over some of the stuff that I think is most important. But we move fast, right? When this class ends, we will be 1/6 of the way through the course. Like things are going to move very quickly, and we have a test that's only a couple weeks away, about midway through the course. So it's going to come very quickly. All right. So just kind of make sure that you have kind of a heads up about how things are going to go. So before we get started, are there any questions? Does anyone, if you have a question about something where you're not sure, you read over the syllabus but you're not quite sure how things work, feel free to ask a question. You can throw it into either chat and I'll either answer it right away or I'll wait a couple minutes till it's an appropriate moment to answer the question or whatever, but we can take a look at all that kind of stuff. So and I will point out, like, one of the problems that we'll be going over today was sent to me by a student, so that seems to work good too. If students want to send me questions in advance, then I can look it over and make sure I know all the things I want to talk about that question, and then I can set it aside, and the student who emailed me, I'll go over her problem. Actually, I don't remember if it was I don't remember who it was, but whoever it was that sent it, he or she, or they, them, we'll go over that question, right? And we can talk about it and take a look at that. So that works better. Sometimes like in class, someone will say, oh, I have a question about the homework. And then I go, okay, what question are you looking at? And they're like, the answer will be, oh, well, it was like that one that had like a 7 in it. And then there was like, it was like you had to divide, and like I'm not gonna know what that means. But if you do like this student did, where you send me the problem, like you can take a screenshot. Screenshots are super helpful if you want to like email me stuff. Screenshots are useful. Otherwise, there's that option in the homework where you can like send me the question. Those work great. If I know exactly what problem you're talking about, then I can definitely like get prepared and go, okay, Because the truth is, if one student sends me the question, there's probably a couple of you that have that same question and would benefit from seeing it, and likely a bunch of you, right? So I'm happy to do that, and that's why our in-class meetings are a little bit more free-form, because since I'm posting all those videos online, you don't really need me to go over those same topics again. But we can use class time for me to help you. So if you specifically have questions, you specifically have things you want me to go over, we should have time for that. There's a couple sections where I might have to insist that we cover certain things during class, but normally we will have time for those kinds of questions. Let's see, and there's a question coming up here. Yeah, so whenever I'm having the Zoom meeting open, there's also a YouTube stream going, right? It's possible in a couple weeks I will have to change that because I might actually be out of town, so I won't have my stream set up with me. But in general, if it's just a normal day, you can join both the Zoom or the YouTube stream. Like I say, whichever one you want. And the YouTube stream has the better visuals, right? And it's automatically archived and closed captioned. So if anyone needs the closed captioning, sometimes it takes an hour or two, but then the closed captioning just automatically should pop up into the videos. If that ever doesn't happen, let me know, and I'll make sure that it gets fixed. But they should be automatically closed captioned as we go. Okay, so a couple of things here. I see that a bunch of people were able to get in and set up the homework. As far as I know, everyone who emailed me was eventually able to get themselves added to the homework, and there's a bunch of you in there, so that's fantastic. I haven't looked in the last couple of hours, so I don't know what the official numbers were, but it looked like people were able to get in there and get started with the situation and get the homework started and all that kind of stuff. So that's good. It looks like everything's working properly with that. One thing that's helpful is now it won't do any good for me to show you because my screen looks different than yours, but you do have access, remember, to the ebook. Okay, it's just an electronic version of the book. It actually gives you two choices. The second one I don't like. They make a version that's like it's formatted for your phone, but a lot of times it's actually pretty different than the actual book. So I kind of don't like that because I know what the book's like, and then if I'm looking at a different version, I start getting confused about like, well, what page is stuff on and stuff like that. So I'll generally use this, which is just the official version of the book, like the actual version. Let me kind of get it centered here. So you can pull it up, and then over on the left you can navigate it just like they've made it actually a little bit easier. These used to be a little bit harder, but they've made it a little easier for getting around in the book now, which is helpful. So, oops, that's not what I meant to do. So you do have access to the ebook, an electronic version of the textbook, and that's very helpful because you want to be able to find examples. Examples are big. If you're really stuck on a problem and you've watched the video that's in the homework where it says, watch a video about this problem. You've done that and you're still confused. The book can be very helpful because you pull up the book, you look at an example, and you can really just take your time and try to understand that example and figure out what's going on and go, oh, now I see what I'm supposed to do, right? The videos are super helpful too. In fact, that's one of the best things that the students say is most helpful is the videos that are associated to that particular homework problem. I think it's off to the right. It says something like watch a video or something like that. Like, just be aware those are there. I have a lot of students that make it through the end of the semester and then they're not even kind of aware that there's those tools there for them. In fact, let's take a look at those because I want to make sure that everyone understands what's going on. So where am I? Let's go here. Let's open that up. If I want to go to, let's see, let's go to assignments, and we'll look at something like this. Oops, popped up over on the wrong screen here. Let's move that over here. Here we go. Oh, that's right. So the different systems have it in different places. So just kind of be aware. I know stuff at the bottom we're sort of, our brains get used to like ignoring because we're used to being at fine print and ads and different things that our brains just learn to ignore. But notice there's stuff down here, different types of help. So there's the help me solve this. If you do that, I think that's the one where if you go through and do the help me solve it, you don't get credit for doing it. But you can do view an example. Right, you can view an example and it'll help you, and then there's get more help, and see how it says video and textbook. So those are two options that you have, and then here's the ask my instructor, right, that you have. So try not to overuse the ask my instructor, because if I get bombarded with too many requests, then I'm not really going to be able to get to most of them, right? Try to save it for when you really are stuck and then send it to me, and then we can take a look at it. But also you have the video and the textbook. Plus, the Ask My Instructor is hard because if you send this to me like on a Friday, then I might not be getting back to you till Monday or Tuesday, right? So, or probably Tuesday when we have class is when I would go over that problem. So, the video and textbook are more helpful, and of course you have the tutors on campus. Okay. All right. So just be aware you have that help down there. Right. Okay, with that said, that's okay, we're fine with that. Where am I? Okay, with that said, oops, I had this, let's see, I'm in chapter 3 because I was organizing videos for Canvas before class. I was putting them in the right place. So let's see, we want to go to the prerequisite chapter to start with polynomials. So polynomials are hugely important. We're going to go over them. I think most of you probably remember the basics of polynomials, but I'm going to go over it just real quick to make sure that you know the basics of those polynomials, because we're going to be dealing with polynomials from here till the end. Like this whole course is very heavy in polynomials. And that's why the next section is one of the most important sections, even though it's a prerequisite section, the one about factoring polynomials. You are going to be factoring polynomials all over the place, right? When you take a math class, there are always certain sections where like you learn that section and then it never comes up again, right? Scientific notation is a big example of this. In an algebra class, we learn scientific notation, and the whole rest of the book, you never do scientific notation again. You do it when you get into your physics class or your chemistry class or whatever, but in the actual math class, you never touch it again. But factoring is not like that. Factoring is going to come up in almost every chapter of this book. Sometimes very heavily it will come up. So you're going to have to be good with factoring. There are some teachers, I don't do this, but there are some teachers who at the beginning of a college algebra class, they give everyone in a class a quiz. Like first day, you walk in, boom, you're taking a quiz. Like 1 minute into class, you're taking a quiz. And if the teacher figures out, oh, you can't factor, then they try to move you into a different class or something like that so that you can get that factoring help that you need, because it's really, basically, if you're struggling with factoring, you're probably not going to pass this class. Now, that doesn't mean if you're struggling with factoring last night that you're not going to pass the class. That just means if you're still having trouble a week or so from now, like Tuesday when we come back, then it's going to start getting harder to do things, because factoring comes up when we talk about polynomials. They come up when we talk about rational expressions. They come up in so many different situations. You just have to be really comfortable with that factoring. So what is a polynomial, right? So here's an example of a polynomial. Sometimes I'll show you the book. We won't just be looking in the book, but sometimes we will be, because it's kind of convenient for me, or for all of us, to be able to show you these things. So this is an example right here of a oops, it's not going to let me highlight it. Oh, there it is. Kind of let me highlight it. Of a polynomial, okay? So what we have for a polynomial is that you have a bunch of terms. The things that are separated by pluses and minuses, we call those terms of the polynomial. So this polynomial right here has 4 terms. 1, 2, 3, 4. And they are separated by positive and negative signs, plus and minuses, right? Now, each term in the polynomial has a couple of characteristics. It has a variable and an exponent on that variable. So for right here, we see x cubed. So x is our variable, and cubed being raised to the third power, that's our exponent, right? And we can see each term actually has that. You might go, wait a minute, the last two don't have a, the second to last term has a variable but no exponent, and the last term doesn't even have a variable. So what do you mean every term has a variable and an exponent? I'll show you in just a minute. It's actually there. It's just kind of, we could say invisible or hidden, right? So just hold on a second, we'll get to that. So this would be called a 4-term polynomial. So there is a variable with an exponent on it. That exponent cannot be negative, and it cannot be fractional. So like you in algebra hopefully dealt with fractional exponents, things like x to the 2/3. Can't have that in a polynomial. You can have that in other types of functions, not in a polynomial. Polynomial exponents have to be whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, something like that. And then we have a number in front. And that number in front is what we call a coefficient. It is a number multiplying that variable. Okay, so remember with our order of operations, because sometimes this will throw people off. Remember your order of operations. What do we have here? We have a multiplication between the 7 and the x, and we have an exponent between the x and the 3. So we have a 7 multiplying an x cubed. So according to order of operations, what are we supposed to do first? Order of operations says we're supposed to do exponents first. So when you are evaluating a polynomial, well, that is when we take a value for x and we plug it into that polynomial, what you have to do is take the power first, multiply by the coefficient second. I see a lot of people who have been out of math for a while forget that. And they, like in this case, they would try to multiply, let's say we plug in 2 for x, they would try to multiply the 7 by 2 and then raise it to the third power. That's doing your order of operations in the wrong way. You need to take the 2 to the third power, then multiply by the 7, okay? Okay, so then we have, and you might go, well, wait a minute, what about that bit then where you said every term here has an exponent and a variable and an exponent on it? Well, this 13x, you can go, well, that doesn't have an exponent on it. It really does. It has a 1 as an exponent. X to the 1 is the same as x. So we could say that's 13x to the 1. We just don't write the 1 in mathematics. Why? If it's understood that if we don't write anything there, it's a 1. You go, okay, but I got you on this one. What about here? There's not even a variable here. There is, we just think of it as x to the 0. Remember, anything to the 0 power is 1. So if we think of this as 6x to the 0, then it's really just 6 and it's fine. And you might go, well, that's just semantics. Like there's reasons why we call it there. When we call about like the degree of a, as you'll see when we talk about degree in just a second, the degree definition matches what I'm talking about, where we would consider this 6x to the 0. We don't write it as 6x to the 0, so it's not really that important of a point, but it can help you think about what a polynomial is. A polynomial is a series of terms separated by pluses or minuses that have a coefficient, a variable, and an exponent, even if we don't always write the exponent and the variable. Okay. Now, here's a thing that can be hugely helpful for just keeping yourself on the right track. One of the, like half the battle, maybe not half, maybe a third, but a significant portion of the battle in mathematics is keeping everything as simple as possible, right? The more you keep things simple, the less mistakes you're going to make. It just makes sense. If you complicate things, you make them harder, it's going to be harder, and you're going to make more errors. So half of mathematics is just being like an organized person who organizes your work. You can read your own work, right? You can read what you've written. And part of polynomials, of having things written in an organized way, is what we call standard form right here. Okay, standard form basically means we have things written in the order of highest exponents first, and in order of decreasing exponents down till you get to the last term. So see how we have our third degree term? The degree of a term is just the exponent that's on that term. So 7x cubed is a third degree term. 9x squared, second degree term. 13x to the 1, first degree. 6x to the 0, degree 0. So see how this backs up what I was saying. There really is an x and a 0 there. We just don't write it. but that last term is a 0 degree term. Okay. The degree of the whole polynomial is the highest degree term that occurs in the polynomial. And as you'll see when we get to that chapter, I think it's the first, is that the first chapter after the first test? I don't remember. But when we get there, you're going to see we're going to really care about the degree of a polynomial. For the next couple weeks, you might go, who cares about the degree of the polynomial? It's not that big a deal. But you'll see later, it's hugely helpful. When we identify the degree of a polynomial, we will instantly know a bunch of information about that polynomial, and that will keep us from making other kind of mistakes or wasting our time doing a lot of work that we can just gain by knowing the degree of the polynomial. Okay, so writing things in standard form, make sure that you have your polynomial in an organized form. There are a couple of instances where we don't want to write things in standard form, but like 95% of the time, we want things in standard form. There's going to be a couple times in this class, and those of you who are going on to calculus, there's going to be a few times in that class where you don't write them in standard form, right? But that's just for like very specialized situations. And it looks to me like I have the date wrong on the stream, so let me just edit that real quick. Today's what, the 23rd? All right. Yeah, 23rd. So let's get that fixed and then get back to our discussion. Okay, so we have a standard form, polynomial, we understand degree, right? And you can see that they're doing the same thing here in the book. They call this is degree 1 because there's really a little 1 on that x. This is degree 0 because it's really like 5x to the 0. So you just have the degree of those terms, okay? We got 3 terms that just help us figure out how many terms there are in a polynomial. So the degree told us about the exponents that are in the polynomial. We have 3 terms that come up, and they're pretty easy to remember if you kind of remember your prefixes of the English language, which are derived from other languages. But we have mono, bi, and tri. So mono is 1. Bi is 2, tri is 3. Like a tricycle has 3 wheels, a bicycle has 2 wheels. So a monomial is a polynomial that only has 1 term. So that would be like 3x squared would be something that is a monomial. Binomials would be 2 terms, so something like x plus 7, that's a binomial. Trinomials would be something with 3 terms, x squared minus x plus 1. That's a trinomial. There's 3 terms in it. So pretty straightforward. Nothing weird going on there. And then they give the official definition for a polynomial, which is just basically everything we talked about. And this looks kind of confusing. Like, wait, what is that? What are all those numbers? These a's are just your coefficients. And then these n-1s, n-2, those are just your exponents. So it just means we could make a polynomial that's 100 terms long. We're not going to do it in this class, but there's nothing wrong with doing that, right? There are times when that kind of stuff comes up. You don't generally deal with them by hand when they come up. You're going to be dealing with them in MATLAB or something like that. But they do come up and they can be important. Let's see, we got a question here. Do we have to finish all those assignments on Canvas by a certain date, or is it due at your own pace? Okay, so there's a good question here. So I just want to address this. And I don't mind, especially the first week, if I have to answer questions a few times, that's totally fine. I know everyone's kind of learning the system and getting comfortable with it. So every assignment you have should have a due date associated to it. So the discussions that are on Canvas will have a due date on there, and if you look at the due date, you'll see when they're due. Like for instance, if I go over there, oops, where am I? Where's my Canvas? I thought I had another Canvas window open. Let's just go to modules. So like here, when you go to right here, this discussion, see how it says June 27th? I'm not sure if it shows on, I suspect it shows on your view, but it'll even say up here like due June 27th. So, oops, if I show it right over there, kind of shows you the due date. And then once you leave a post, it'll timestamp it so that it says when you did it. So those have a due date on it. And then all of the assignments that are inside of my math lab those all have due dates that are listed on there. So you should be able to see when all that stuff is. And in this, I apologize for you having so much homework due. That's just the nature of taking a summer class. You're going to have, it makes sense. You have 3 times the homework load because we're doing this class 3 times faster, right? So you really want to stay up on those due dates because I don't really have a lot of time to push them back because we just have other stuff that we have to get into. So to answer the question, for all assignments in this course, you should have due dates associated to all those assignments, both in Canvas and in the My Math Lab that we're looking at. Yeah, so good question. Let's see. Okay, adding and subtracting polynomials. This one's easy, right? People generally, like, you might make a mistake here and there, but people don't generally struggle with the adding and subtracting polynomials because it just basically works like you would expect it to, right? So let's do an example here. Let's take 3x squared minus 4x plus 7, and we're going to add to that 2x squared minus 3x plus 1. And I have to remember to take roll in a minute, so I'll pause in a minute to take roll here. So what do we have here? Oh, it's still not showing up on my screen. Let's see if we bring that in and there. There we go. So I have 2 polynomials, right? 2 separate polynomials here, and I want to add these together. The key for polynomials is combining like terms. That's what you want to do, is combine like terms for these things. So I'll put that in there, that's kind of the key. It's really all you got to do, is combine like terms. So that is, you're looking, what is a like term? Those are things that have the exact same variable type. So when I look up here, I see 3 different types of terms. I see 2nd degree terms, 1st degree terms, and 0 degree terms. So what you're going to do is you're going to combine those together using the symbol that is in between. So this is a plus. That means I'm going to add my terms together. So I'm going to take the 2nd degree terms. I have a 3x squared over here, and I'm going to add to that a 2x squared. So remember when we're, like, sometimes people forget and they go, oh, if I combine those, don't I get like an x to the 4th or something? No, right now we're adding. If you multiply x squared by x squared, you get x to the 4th. If you add x squared and x squared, you get 2x squared. Think of it, when you're adding, what you're really doing is counting, right? Like if you have 3 apples and then someone gives you 2 apples, you have 5 apples. You don't have 5 apples squared, right? You don't square the object that it is. Over here we have 3x squareds, and then I get 2 more x squareds. That means I have a total of 5 x squareds. Okay, so this is going to be 5x squared. Oops. 5x squared. And then I just move on to my next type of term that I have up here, which is the 1st degree terms. Okay, I have negative 4x's over here, and I'm going to add to that another negative 3x's. So, sometimes if you haven't taken math for a while, you might be a little rusty with your adding and subtracting negatives. Just think of it in terms of a bank account. If you owe $4, so your account's at negative $4, is at negative 4, you owe $4. If you owe $4 and then you spend $3 more, right, because it's negative, that's a loss, you're spending. So if you're at negative $4 and you spend another $3, you're at negative $7, right? So in this case, if we have negative 4x's and then we lose 3 more x's, we're at negative 7x's. So this is going to be negative 7x. And then, of course, 7 plus 1 is pretty easy. That's just going to be plus 8. So when it comes to adding and subtracting, it's real straightforward, right? If this was a subtraction sign, then all those operations where you're combining like terms, you would just subtract them instead. Another way to do it is to distribute the negative in and then add. So, the reality is this is a class where there's more than one way to write up a lot of these problems that you're working on. So I know a lot of times students will watch me do a problem and go, well, I got the same answer, but I did it a different way. That's okay. It doesn't mean your way's wrong or that one's better. There are wrong ways to do mathematics, but there is oftentimes more than one right way to do the problem. So if you organize your work a little bit differently, that's fine. In fact, we'll see that when it comes to factoring. Many of you through your K-12 career have picked up, little things that your teacher taught you to help you remember how to do certain things. But fundamentally, it's the same mathematics behind the scenes. We'll talk about that in a few minutes. So that's fine. Don't be afraid to do things slightly differently. You don't have to do it exactly my way. As long as you're doing a legitimate way that that is appropriate for this class. Sometimes I'll have students that took calculus in high school and then they're trying to use calculus on, but this is essentially a pre-calculus class, right? So we can't use calculus in here. If you know calculus, you should go be in a calculus class. In here, we have to use the tools of pre-calculus, but as long as you're using a reasonable way to do the problem in a way that's appropriate for what we're doing, don't sweat it, okay? The key is about getting you to figure out how to do stuff, not that you have to do it exactly the way that I do it. That's the one we're going to do later, okay? So then we've got adding and subtracting polynomials, and then there's multiplying polynomials that we get into, and that one's pretty important, but most people are pretty good with this too, because it's just really a matter of remembering the basics of that multiplication. And for the sake of time, I'm not going to spend too much time on this because there's good videos, or I think they're good videos because I made them, inside of Canvas, really showing you the steps for multiplying out those polynomials. So I kind of don't want to spend a lot of time in class on it because I think you'll be fine watching those videos. The thing to remember is when you're multiplying polynomials, your exponents do change. Remember how we just talked about with adding and subtracting? You should end up with the same exponents at the end that you started with, unless they just happen to cancel out perfectly. But if you're adding terms and you didn't have any x to the fifth, you shouldn't end up with an x to the fifth in your answer, okay? But when you're multiplying things, you might, because when you multiply things, it does change the exponent can change. So oops, that's not what I want. I want this one right here. So let's go down here. Let's just start basic. I'll just do some real quick stuff here with polynomial multiplication. Let's say I've got 3x to the 5th, and I want to multiply that by 7x to the 7th. So some of this relies on those rules of exponents, which I know for some of you has been a while. That's okay. You just kind of have to remember how to do this stuff. So what we're going to do is we're going to multiply the coefficients. So 7 times 3 is 21. So we're going to get 21x. And now I have to figure out what my power is. Let's see. What's x to the 5th times x to the 7th? Well, that's really 12 x's being multiplied together, right? So that's really going to give us x to the 12th. Sorry, I had a typo. Right, there we go. So 21x to the 12th. We have one of our rules of exponents that says when we multiply x to the 5th times x to the 7th, that's when we add those exponents together. Remember, when you multiply exponents is when you raise an exponent to an exponent. So this is the case where we add those together. And the basic, like I say, watch here, I'll show you just to make sure everyone understands. If you come down to polynomials, I've got some videos in here. There's a few on adding and subtracting, and then down here there's a few on multiplication. So I walk you through these multiplications and the steps that we do, okay? And we even get into it looks like I have a trinomial times trinomial here. So those are videos I made a long time ago. The world has improved and electronics have improved quite a bit since then. So, the sound quality is not as good as I would have today, but that's they will teach you how to do the polynomial multiplication that you need to do. The short way to think about it, because a lot of times it's broken up into all these different polynomial multiplications, and you had teachers that taught you, okay, in this particular instance use FOIL, and in this particular instance use the grid method, and they all have these nice tricks for helping you remember how to do the polynomial multiplications. At the end of the day, polynomial multiplication just comes down to this. You take every term in one polynomial and you multiply it by every term in the other polynomial, and then you add them together. And I know, because whenever we teach this, I have a student who says, well, my teacher taught me the box method or the whatever method. It's all the same mathematics behind the scenes. In fact, sometimes if we're in class, I'll do this. I'll write out my method, and then I'll write out their method, and you can actually point and show where like all the different terms are showing up. It's all the same work, it's just organized differently. It's the same mathematics behind the scenes. So, you know, your teacher didn't really teach you a different method for multiplying polynomials. He or she just taught you a different way of organizing your work so that you remember it better. But it's still the same math taking place, right? It's not like your teacher found an alternate mathematics system, you know, that somehow does this. It's the same stuff. It's just, you know, the book sometimes writes the work horizontally because they want it to fit on the page better so they can save cost. Some students like to write it vertically. Some students like to write it in a grid. It doesn't matter. It's all the same stuff. Okay, so make sure that you can go through and multiply those polynomials. That's going to come up quite a bit when we're doing stuff. See, here's the vertical method. That's fine. Here's the horizontal method. Here's like the vertical method. Oh, a word about FOIL, and it may seem like I'm being picky, but it really is a matter of confusion. FOIL, students will use the FOIL to mean anything to do with polynomials, but that's really confusing because when someone says FOIL, I think they're talking about FOIL. FOIL is just one type of polynomial multiplication. It's not even all polynomial multiplication. Students use that a lot. They'll say, oh, I FOILed this. FOIL helps you remember the way in which you're multiplying things. First, outer, inner, last. That's 4 multiplications. The only time FOIL works is a binomial times a binomial. So if you're doing a binomial times a trinomial, you're not doing FOIL, because in that situation you should be doing 6 multiplications. So it would be like FOILer or something. You know, it would be something totally different. So FOIL just means binomial times binomial. Otherwise, you want to use the term polynomial multiplication. And again, I'm not saying this to be pedantic. It's more like, so I know what you're talking about. When you ask me a question, if you say FOIL, I'm going to start thinking about FOIL rather than, polynomial multiplication, then I realize it's more broad, right? So just try to, you know, it's not a huge deal, but just try to remember that. It makes it a little easier for us to communicate. Let's see. Where's my, here we go. Multiplying, right, we got that. There's a couple special patterns that come up when you're doing polynomial multiplication. I don't think we need to spend time specifically on those. Oh, what I will show you is this though. Because students sometimes like just have kind of, they know what to do, but they just kind of forget. So when you see something like this, say we have 3x minus 2 quantity squared. So see how it is right here where we have 3x minus 2 quantity squared? And I'll have students that stare at this and they call me over and they're like, I just don't remember. I don't know what I'm supposed to do because we didn't talk about raising things to powers. We talked about multiplying polynomials. This is the power of a polynomial. So what am I supposed to do here? And then, you know, I kind of prompt them a little bit and say, write out what that exponent means. Like write out the expression in a different way using that exponent, and then they usually kind of figure out, oh, I think what he's telling me to do is to do this, where I write it out. Something squared just means that thing times itself, right? So 3x minus 2 squared means 3x minus 2 times 3x minus 2, and as soon as the students write it this way, they go, oh, I know what to do now. And then they finish the problem. So don't let this with the exponent throw you off. Just think about interpreting it as this, and then you'll be fine for your multiplication. Okay. I definitely see students get stuck on that sometimes. They give you some of these formulas in the book, like the square of a binomial difference. You can learn those if you want, but you kind of don't have to, because if you just apply the normal multiplication to them, you'll get the right answer. So, you know, it's not really a big thing. You will occasionally see polynomials in multiple variables. For the most part, we won't do that, okay? Those of you who you go through the calculus series. In Calc 3, you'll do a whole bunch of multivariate stuff, so more than one variable going on. For now, they come up from time to time, but they're usually not that big of a concern. You just work through them. Oh, we've got some cute puppies there. Right, okay, so let's go to the big one, the factoring. So here's the one that you definitely want to take seriously. I mean, you got to take all this stuff seriously, but the factoring a lot of times is make or break in a class like this, right? If you can factor, then that's not going to hold you back. If you can't factor, it will 100% hold you back. So let's see, where are we? So factoring polynomials. So let's just kind of remember what we're doing, and we'll go through a problem here. Let me start a new page here. Oops, let's start with this one. This might be too big, but let's see. So I can explain what's going on. Let's do 2x minus 3 and 5x minus 7. I'm using LaTeX is this language that was written for mathematics. Basically, it's like a scripting language that's specifically for mathematics. Anytime someone publishes a paper in mathematics or something, it was written in LaTeX. And you'll see sometimes it's a little bit slow. It takes a second, but when we get to certain things, rational expressions, logarithms, exponentials, it's way faster than like trying to use Microsoft Word or something like that. So that's why occasionally there's a little bit of a delay, because it's going through and it's trying to render the proper thing. For the polynomials, it's not a big deal. But okay, so oops, let's do it this way. Okay, so let's say I want to multiply these together. So we're going to do our FOIL process: first, outer, inner, last. That's the 4 multiplications that we have to do, right? Again, that's just an ordering of taking both terms in the first polynomial, multiplying them by both terms in the second. So if I do that, I get the following. 10x squared, right? 2x times 5x is 10x squared. Then I multiply the 2 times the back, so that's minus 14x. My inner is going to be minus 15x. And my last, negative 3 times negative 7, is plus 21. Okay, so that's my 4 steps of my FOIL. We've got my first, outer, inner, and last. Okay, great. But if you'll notice, we have some like terms there if that's not simplified. I know, students don't like it when, in grade school and stuff where you're learning fractions, and we always tell you got to simplify everything. It's like, well, why does everything have to be simplified? And it goes back to what I was talking about earlier. Half of mathematics, or a huge chunk of mathematics, is just being organized, right? Keeping yourself organized and simplified so that the next step isn't any harder than it needs to be. Because if it is, that increases your likelihood of making mistakes. Okay, so in this case, we can see, as frequently happens when we multiply polynomials, we have terms that need to be combined. And in this case, we can see it's the middle 2 terms. Okay, so I'm going to go ahead and combine those, giving me 10x squared minus 29x plus 21. I'm going to go ahead and make this bigger, I think. And see it a little bit better. There we go. Okay, so see how we started with this version up here? This is like, it's a polynomial. It's not written in standard form. It's in factored form, which is usually how we're going to want to finish problems. We usually want it in factored form, but pay attention to the homework and how it tells you it wants it done. And then down here we have our polynomial in standard form, right? Well, there's a key difference between these 2 forms of the polynomial. Notice that up here, the polynomial is written as a product. There's a multiplication implied by this problem. That is, I take 2x minus 3 and I multiply it by 5x minus 7. That product is a huge deal. It's like a very, very big deal for us to be able to write polynomials in a multiplication form as a product. Whereas down here, there's sums and differences. It's 10x squared minus 29x plus 21. So here our terms are separated by pluses and minuses. Here we're connected by a multiplication. That a lot of the work we do with polynomials can only work when it's written as a product. That's why we want to factor things all the time, is because that product opens up new tools for us to apply to our polynomial that will allow us to progress through whatever it is that we're trying to learn, right? So if you start with something like this where it's in the product form and you multiply everything out, that's called polynomial multiplication. That's what we just talked about a little while ago. But if you start at the bottom and you work your way up, that's called factoring. So the whole point of factoring is to take a polynomial that is written as sums and differences and write it as a product. Okay, so that's the whole point. That's what factoring is. You take something like this and you turn it into something like this. That's what we want to do. You turn it into something that's written as a product. Okay, now there's a whole bunch of different techniques for factoring. I have a whole bunch of videos on here for you, and we are not going to have time to talk about them all. I can see already. Because normally we would spend like 2 weeks doing this in class, right? Or, yeah, at least 2 weeks. Well, yeah, it's a whole chapter, so we'd probably cover about 2 weeks usually, like in an algebra class. So I've got them here. We've got greatest common factor. We've got factor by grouping. We've got trinomial factoring. Trinomial factoring, the hard and the easy trinomial factoring. Trinomials, so that's the 3-term polynomials. That's the ones you see the most. Those are both the easiest and the hardest, at least in my opinion, and I'd say most students tend to agree with me. So I'll spend a little time on that in a minute. The problem that was requested from a student that I cover is a trinomial problem, so we'll take a look at that in a minute. There's difference of squares, which is pretty easy. People usually pick that up in about 5-10 minutes. If it takes you a little longer, don't sweat it, that's fine. But people usually are fine with the difference of squares problems. Anyways, I won't confuse things. I think that's where we're... So anyways, if you look in Canvas, you have lots of options for learning how to factor. And if you're still confused, look at the videos that are inside the homework. Get help with the tutor. Watch other videos online. If they're, just go on YouTube and look up factoring polynomials or whatever it is that you're trying to do, and there'll be help for that. But you need to get good at factoring polynomials. That's a must for this class to be successful in this class. So let's do a couple of examples, because it gets confusing. Like the easiest ones are pretty easy. So many of you, when we do the easiest factoring problems, you'll probably be good enough that you can actually look at it and just tell what the factoring is. You always want to double check because it's easy to make mistakes, but you'll be able to do that. The hard ones, probably not going to be able to do that. So let's start with an easy one. Let's take where we want to factor x squared minus minus 7x plus 12. Okay, so I want to factor x squared minus 7x plus 12. So when you're doing this, when you're doing factoring, you kind of want to be, it's like you're a little detective, right? You're looking at the polynomial that you're supposed to factor, and you're looking for clues. Okay, what are the clues that will tell me the original factored form? Okay, it's hard to do. Like from a mathematical standpoint, it's not just that factoring seems harder than multiplication, it's literally harder, right? In fact, encryption and a lot of the things that have to do with like keeping the internet safe and stuff like that have to do with factoring, and the fact that multiplying is way easier than factoring is, right? So if it seems harder, it is harder. It's like objectively harder, okay? Namely because when you multiply out a polynomial or a number or whatever, you have all the information you need in front of you. You're just following an algorithm. Like if you were to write computer code, it's very easy to write code to multiply things. You're just going through and having it like figure out, take this number, multiply it by this number, add it to this number over here. It's like it's all algorithmic. Factoring, you're operating in a situation where you don't have complete information. you're missing some of the information that you need, and that's what makes it difficult. Is you sometimes have to try multiple times to guess at what you're missing. They call that method guess and check method. And sometimes you're going to guess wrong, and don't take it too seriously. You just try again. And in fact, that's something I should bring up, because I see that hold a lot of students back. If you are taking a math class, if you are doing math, if you are doing science, if you're doing any of that kind of stuff, you are going to make mistakes. Okay, just get over it right now. You're gonna make mistakes. Like, if you're not making mistakes, then you're not really doing anything in the mathematics. It means you're in a class where you kind of already know how to do everything, and what's the point of that, right? So, like, I have a PhD in mathematics, right? Except I make math mistakes all the time. The difference is that when I make a mistake, I usually can recognize it and then fix it before anyone else ever figures out that I made a mistake, right? And that's kind of what you want to do. You want to cut yourself a break and say, I'm going to make mistakes this semester. It's going to happen. I'm not going to get upset about it. I'm not going to throw my book across the room. I'm not going to bang my head on the wall. I'm just going to learn from that mistake and try not to make those mistakes again. Okay? But just mathematics, you make mistakes. You do silly things. Like on tests, I'll see people that write 5 times 4 is 9. Now, I know that person knows that 5 times 4 is 20, but they were nervous during a test and they accidentally wrote 5 times 4 is 9, and their brain was thinking about addition. Like, these things happen. So cut yourself a break. Don't get super intense about it. You're going to make mistakes. That's actually part of the learning process, is making the mistakes. So just try to learn from those mistakes and don't beat yourself up too much. Okay, but we are going to have to do some guessing and checking here a little bit. So what do we need, right? You'll be amazed at how much it helps to write things down on the paper, especially a lot of times when students are doing online homework. They're like, oh, well, it's hard when I'm not writing anything down. You should be writing things down. You're not writing it on your computer screen, right? There's a little box where you're going to enter your answer, but you should be writing things on scratch paper. You should be filling pages and pages with scratch paper every time you do an assignment, right? You should be writing the things out. I see a lot of times students who don't want to write anything down. I think it's just kind of a little bit of a laziness thing, like, I just do this in my head. Don't. You should not be doing math in your head. You should be doing it on paper. The more things you try to hold in your head, the more space you're taking up in your brain for stuff that it doesn't need to, right? And I mean even little tiny steps. Just put it on the paper, and now your brain is freed up to think about the other pieces, right? So for instance, write parentheses. If in your factored form, there's parentheses. Write them down, right? You're going to need them. Now, you see, because of the way that I'm writing this on a computer, it didn't put any space inside the parentheses. You should leave yourself some space inside the parentheses, because you're going to be filling it in with stuff. Mine are going to grow as I fill values in there. But you should write some parentheses with some space. And students go, I know there's going to be parentheses. I don't have to write that part down. Trust me, I've seen this. When students write even the little things that you think are inconsequential, as you write them on the paper, it frees your brain up to go to that next step. And then you do that step, it frees you to go to the next step. I mean, this happens where I'll help students in class where I literally don't tell them anything. I just say, okay, can you do the next step? Okay, I'll do the next step. Okay, can you do the next one? Yeah. And then they finish the problem and I never even helped them. The only thing I got them to do was write on a piece of paper. That's all I did, right? So the paper and the pencil are your friend when you're doing this kind of stuff, all right? All right, so what do we know about this? Well, we're kind of reverse engineering factoring, right? That's what we saw up here. We're starting down here and we're trying to work our way backwards up through the factored form. So you have to think about factoring backwards, which is not easy to do. And I go, okay, well, how would I get an x squared if I was doing FOIL? Well, the only way that's going to occur is if I have an x and an x. Okay, so I've got x's at the beginning of these. Okay, so I know I've got x's. All right, what about signs? Can I fill in the signs? And the answer is yes. At this point I can. Because where does this 12 come from? It comes from the L part of my FOIL. It comes from the last. Like up here, it's the 3 times 7 gives the negative 3 times negative 7 gives me the 21, right? So down here, what did I multiply to get a 12? Well, what we're concerned about at the moment is the sign on the 12. Notice how this is a positive 12 right here. How do you get a positive number when you multiply things? You get a positive number when the signs are the same. So 2 negatives or 2 pluses, right? So those are our choices. They're either, down here it's either going to be x plus and x plus, or it's going to be x minus and x minus. How do I know which one? Well, if it was x plus and x plus, then how would I get a middle term that was negative? That can't happen. So the only case must be if it's x minus and x minus, right? Excuse me. I might have to get a water in a few minutes. I'm getting a little parched here, talking so much. So then think about your middle terms and your last terms. So what numbers could I put in here that when I remember this step when we combined the outer and the inner? Well, that's going to happen here. When I combine my outer and my inner, I'm going to want a -7. But when I multiply them, I'm going to want a 12. So you go, okay, I'm thinking about numbers that when I add them give me -7, and when I multiply them give me +12. Well, that's going to be 4 and 3, right? So we write them in there, 4 and 3. Now here's a fantastic thing about factoring. It's real easy to check your work. All you do is just multiply it back out. So just FOIL this, and you'd get your x squared minus 3x minus 4x plus 12. Simplify everything, and you'll get what you started with. Super easy to check your work, okay? And then the question comes up frequently, oh, well, I got a different answer than you because I got this. This is exactly the same thing. So basically, if you just take the factors and write them in a different order, it's the same answer. Now, if your factors inside are different in any way, then it's not the same. If this was like I'll have some students to say, well, I got the same answer as you, but mine's an x plus 4. Well, x plus 4 is not the same as x minus 4, so you did not get the same answer, right? This is the same answer because they're the same factors, but in a different order. Think of it this way. 5 times 4 is the same as 4 times 5. If you change the order of multiplication, you don't change the product, right? But if you change the numbers that you're multiplying, then you change the product. So both of these totally legitimate answers as the factoring of this thing right here. That's totally fine. Okay. So these are the easy versions of the trinomial factoring. Most of you will pick these up pretty quickly. Watch the videos that are in Canvas. Do half a dozen homework problems and you're going to go, okay, I know how to do that. Those are fine. The thing that makes these the easy ones is this x squared term. See how the coefficient on my x squared term, what is that coefficient? It's really a 1, right? If the coefficient on your x squared term is 1, those problems are generally going to be fairly straightforward. Oh, one thing I want to remind everyone of, because sometimes people forget this and then they end up spending 45 to 60 minutes on a single problem. Not every problem is factorable over the integers, and that's what we mean when we say factorable, is over the integers. When a number is not, it is prime. And we call it prime because it's literally just like prime numbers, right? The number 17 cannot be broken down as a product of smaller numbers, right? The only way you can break 17 down as a product of integers is 17 times 1. It is prime. It's the same thing with factoring. If it cannot be factored down into smaller factors, then it is prime. Right? So that you'll have some homework problems where it's like that, where, you know, because it says enter the factored form, or the other option is that it's prime. It might be prime. So, you know, you might have a prime number there, or a prime polynomial. So just keep that in mind. All right, let's look at the one that was asked about in class. So this is the harder version. This is the one I got the email about. So factor (28x squared plus 25x), what was it, minus 8? Okay. Where am I? Minus 8. Still, how's that look on the screen there? Yeah, okay, that's doable. So this problem can be significantly hard. Not necessarily this one, but it's going to take you longer because of the whole guess and check. Remember I was talking about looking for clues and working through your guess and check? These are more complicated, so your clues are not quite as powerful, and you might have to try a couple attempts before you get the right one. Right, that's entirely possible. That's kind of how the guess and check works. But here's how you want to think about this. Okay, if this is factorable, it needs parentheses, so I'm going to go ahead and throw those in there. Now, in our last problem, it was a real easy start because the only way to break down the x squared was with an x and an x. But 28x squared can break down a bunch of ways. 7 and 4, 14 and 2, 28 and 1. Is that all of them? I think that's all of them. So we don't know how to break down the x squared. So what are we going to do? We're going to have to take a guess with it. So let's just say, okay, I'm going to guess that it's 4x and 8x. So I go ahead and I put those in there. And this one's especially tricky because notice over here, the -8, that means when I take my last terms and I multiply them together, the L part of the FOIL, I get a negative number, which means how do you get a negative number? It means you multiply a positive and a negative. The signs have to be different. That's the only way you get a negative when you multiply things. So, well, does the negative go after the 4x or the 8x? I don't know. All these like I don't knows, these are extra attempts we're gonna have to try to go through and figure it out, unless I get lucky and get it on the first one, because I don't remember exactly what the answer ended up being when I worked it out earlier today. But I'm just gonna take a guess, and as you get better at these, some people will get to where they can look at this middle term and kind of start to like predict what they think is gonna happen, but that comes with experience, that comes with practice. Many of you by the end of the semester, you'll be real good at factoring, because you'll do it a ton and you'll start to pick up these clues like, oh, I can kind of see what it's going to be. And you'll start to get these more on your first guess, maybe your second guess. But you'll get better at it, right? Trust me, as someone who's, I teach this for the last, 15 years or more than 15 years. Like when you see these polynomials a lot, like you get to where you can pick up the clues better on them. But in the beginning, it's going to take you longer, okay? So let's see, I'm just going to go with, let's just say that's the plus. Oops, how did that happen? That's the minus. So that's my guess, that it's going to be 4x plus something and 8x minus something. So let's see, what are the different ways I can break down 8? It can be 8 and 1, 4 and 2. It's like that's about it, right? So I'm going to try to put things in a way that I think might make sense. Let's see, what if I put it in here? 8 and 1. Equals, and then let's see what's going to happen when I multiply. Oh, sorry, that shouldn't be an 8. That should be a 7, shouldn't it? Sorry, I put 8 in there. That would be 32x squared. It should be a 7. Is anyone confused by my mistake there? When I broke down the 28, for some reason, I must have pressed the wrong button. I put 4x and 8x when it clearly should be 4x and 7x, right? Okay, so let's see. When I see what I did there, how I'm multiplying it out at the end. That first of all verifies I got it right, but also catches these little mistakes, right? I just talked about if you do mathematics, you're going to make mistakes. I just made a little mistake, but I caught it, right? It's all these little tools. Like a lot of times I'll watch students in my classroom and they'll talk about like one student being really, really good. And they're like, oh, she's so good. She just like gets the problems right all the time. They don't realize that student has spent a ton of time getting really good at this, and a student probably catches her own mistakes before anyone else notices it and fixes it before anyone else realizes it's wrong, and so it just looks like she never makes mistakes. But you just have to get good at making mistakes well, right? Being good at making mistakes and being comfortable with it. Okay, so what do we got? This would be 28x squared. My outer would be minus 4x. My inner would be plus 56x. Already looks like this isn't right. And then we're going to have minus 8. Okay, that didn't work out, so this is wrong. Okay, no big deal. We're not going to get upset about it. That was just our first guess. Let's try something a little different then. So let's try it a different way. We're going to go 4x, let's see, go 4x plus 1. I'm just trying a different combination this time. I'm going to switch where the 8 and the 8 and the 1, and I'm also going to try the signs. You're just trying something different, right? It's your best guess. So 7x plus 8. So what are we going to get? We get 28x squared plus 32x. Oops, this should be a minus, right? This one over here should be a minus. It'll update right now. There we go. So we get 28x squared plus 32x minus 7x. Looks like that might be the one. And then minus 8. Okay, so it looks like when I simplified this, that's going to give me 28x squared. Okay, so 32x minus 7x. If I have 32x's and you come and you steal 7 of those x's, I now have 25x's, right? So 25x minus 8. And that's what we wanted. That's what we started with. Oops, I'm missing a plus. Okay, that's what we started with, so we know this is the right factoring for that problem that was asked about. Okay, so that's the right one right there. That's how you're going to do that. Okay, let me take roll right now before I end up forgetting. Okay, what do we got? Okay, let's look over here. What do we got? And thanks everyone for putting your names in there. If you haven't yet, go ahead and throw your name up there, but it looks like most people probably did. Let's see. Okay, let's see. So the main ones, I'll just go over who I don't have marked as being here. And that's including the people who are dropped. So if, just to make sure so they know they got dropped. So there's Angel A, Jag B, Lexi C, Eden C, Bridget K, Sunamari M, Leanna O, and Priscilla R. So I just named the people that I don't have as being here. So if you're one of those people, let me know so I can get you as here, because there may be people who get dropped later this week as well. I had to do drops yesterday as part of the contract, but we're supposed to also progressively drop people throughout the semester who aren't showing up. So make sure you're participating and we can get through all that. Okay, good. We have a little time left. Okay, any questions on what I've talked about so far today? No. Okay, feel free to throw questions in the chat if you've got them. Let's just double check back in our book here and see where we're at. So I've got the factoring. So that's kind of your basics of factoring. We've got factor by grouping. So for some of your factorings, you have a choice, right? In fact, some people, you can take a form of factor by grouping and you can even factor trinomials with that. I have some students who do that. They basically, you can learn factor by grouping and you can factor almost anything with it. It takes a little, you have to do a little bit of adjustment to fit it to trinomials and stuff. But like for the kind of problems we just did, sometimes factor by grouping is like the easier way to do it. Like this one right here, if I was doing this and I wasn't like teaching a lecture, I'd probably use factor by grouping to factor this. Usually if the A is not equal to 1, that's the coefficient in front of the x squared term is not 1, then a lot of times I'll just use the factor by grouping method to get it. So you're welcome to do that. But there are some problems where you have to use factor by grouping. So I just want to kind of briefly go over it just so people kind of remember. Let's see, we have a question here. Do you have any tips for finding values for factoring quicker during tests? Yeah, that's a great question. The key to factoring is having the experience of having done a bunch of them. Is really all it comes down to. Like knowing how to do the problems, and then you just practice them like a lot. You will find that you get very fast at them. Like to the point where I've mentioned, like I'll have students in class that can just visually look at a polynomial and they'll just tell me the factoring. Not the hardest ones, but like the easier to mid-level factoring problems. I'll put it on the board and they'll go, oh, I know how to factor that. But it's because they've done a ton of them at home, right? You do a bunch on the homework, and then maybe you pull the ones out of the book. For instance, you can. All of the book problems all have homework sets at the end. So if you wanted extra practice, you could come in here and you could work the examples out of the book, but then also you could go to the where they have the exercise set, and you could practice lots of these. And I know that's not like I wish there was an easier way to do it. But it's really just comes down to when you've factored lots of problems, you'll get really good at factoring them quickly, is unfortunately the only answer to that. Sorry, I don't have like a cooler answer. And it was a good question. But we will go over this strategy in just a minute, and that can be kind of helpful. This strategy can save you some time when you're thinking about it, like how to factor something. We'll go over that in just a minute. But we have a couple things to talk about before we get there. So where were we? Factor by grouping. Factor by grouping is what you're going to use when your polynomial has 4 terms. So if there's 4 terms in the polynomial, you basically have to use factor by grouping to do it. So factor by grouping, I've got the videos on Canvas, watch those, and you should be just fine with factor by grouping. one of the other ways, and then they walk you through factoring a trinomial whose lead coefficient isn't 1. That's basically what we just did a minute ago. And then there's difference of squares and stuff like that. So difference of squares, basically we name it what it is. If you look at it, it's literally a difference of two squares. And there's videos on the Canvas page about how to factor a difference of two squares. People pick it up really quick. Like literally, like usually by the time I'm done explaining it, people are like, I get it. I get how to do that. So difference of squares is not usually a problem for people. You just kind of have to recognize it. But you'll pick that one up quick. Repeated factorization. So here's the thing, that they'll start putting problems, you'll start seeing these problems pop up where you factor it, and then you notice one of your factors can be factored further. So that's what they call repeated factoring. Like in this case, they've got x to the 4th minus 81. Well, that's a difference of squares, giving us x squared plus 9 and x squared minus 9. Well, x squared minus 9 is a difference of squares. So you can factor that one further. X squared plus 9, we don't have a way to factor that. But this x squared minus 9 can be factored further, so they do. Okay, so that's all they mean when they say repeated factoring. There's a section here on perfect square trinomials. Here's a little thing I'm going to tell you. I'm not telling you not to learn perfect square trinomials, but what I'm going to tell you is you don't have to. The way that you factor trinomials will also work for the perfect square trinomials. Right? In fact, there are times when I have to factor something and I don't even recognize that it's a perfect square trinomial. I just factor it like normal, and then at the end I go, oh, look, it was a perfect square trinomial. Why didn't I see that? But you don't have to. So you don't have to learn a separate way to factor the perfect square trinomials. Just factor them like trinomials and you'll be fine. But you can learn that different way if you want. I'm just not a big fan of learning like unnecessary procedures. Like, why? If I already have a tool that will work on this and the way you're telling me isn't really like any easier, then why would I learn a separate thing, right? I'm a fan of like, learn the tools you need to do the job. Don't like make up new stuff just to talk about. Okay. There's factoring the sum and difference of cubes. Those will come up a couple times throughout the semester. But they don't come up a lot. And you know, so you can mess around with those. They're basically, there's a formula that you follow. Oh, excuse me. Okay, so this can be helpful. This might help a little bit to Delaney's question a few minutes ago about are there any tips for figuring out? This doesn't necessarily help you find the values in your factoring. Again, that's a lot of it is just going to come with the more factoring you do, the stronger your number sense for factoring is going to be. But this will help determine which method you want to use for your factoring, because we've looked at a few different ways. There's difference of squares, factor by grouping, greatest common factor, trinomial factoring when your lead coefficient is greater than 1. It's like a bunch of different techniques. So how do you know which technique to use when you go to factor a particular problem? Well, that's what this strategy is supposed to give us, is it narrows down for you the methods that you should use for a particular problem. And it's pretty easy to go through and do. So if your polynomial has a greatest common factor, factor that out. So like if all your coefficients are even, factor a 2 out, right? Any common factors that you can factor out, do that. What that's going to do is it's going to reduce the size of your coefficients and exponents, making the rest of your problem a little bit easier. So that's always step one. See if there's a greatest common factor, and if so, factor it out. Now, most of the time, there isn't going to be a greatest common factor. But, you know, that's okay. If there isn't one, then you don't factor it out, right? So step 2, now you have to determine which method to use. And what it's going to come down to is determining the number of terms in the polynomial that you're factoring. So we've looked at factoring things where there were 2 terms, 3 terms, 4 terms. That's what you're going to identify. So they say determine the number of terms in the polynomial and do the following. If there are 2 terms in your polynomial, then it is probably a difference of squares, a difference of cubes, or a sum of cubes. In other words, you're going to use one of those 3 formulas in order to factor it. Okay? What if there's 3 terms in your polynomial? Well, that makes it a trinomial. And if it's a trinomial, then you're going to use one of the, the two methods for factoring trinomials. Either your lead coefficient is a 1 or your lead coefficient is not a 1. Either way, just factor it like it's a trinomial. Here in the book, they tell you to see if it's a perfect square trinomial. Again, that just strikes me as extra steps. Who cares if it's a perfect square trinomial? Just factor it as a trinomial. Don't worry about if it's a perfect square or not. I mean, you can if you want to do that, but it always just seems like extra steps. Like I said, like you're doing extra steps that really don't matter. So just factor it like a trinomial. If there are 4 terms, then it's factor by grouping. So you can immediately tell when you have to use factor by grouping, oh, there's 4 terms, so of course I'm going to have to use factor by grouping, right? Is how that's going to work. So, and then they say at the bottom, just check to see if anything can be factored further. Did any of the factors you come up with, are they factorable again? If the answer is yes, then factor them. If the answer is no, then you're done. You don't have to worry about it. Okay? So, and then they give you some examples of using this strategy. Here they use factoring for something that's not even a polynomial, but we won't use that a ton. It'll come up from time to time, but we won't really use it that much. So that's the chapter on factoring, and we spent like an hour talking about factoring, but that's because it's really just, it's important. Like you are going to be factoring regularly in this class, and it like as step 1, like the beginning of the problem will be factor a bunch of these polynomials, and if you can't do that, you can't even get into the problem at that point, right? Okay, then the next section is about rational expressions. I put some, I should have, let's see, should have some videos in here about this stuff, so I don't want to spend too much time on this because literally I would just be reproducing what's in here. But we've got adding rational expressions, which also covers subtracting them, and then multiplying rational expressions. Oh, I've been looking at so many sections in this book. Is maybe solving equations is later? Must be later. Yeah, okay, that's right. I'm thinking of a later chapter in the book then where we had to solve equations. But yeah, for the rational expressions, so we talk about adding, subtracting them. One of the key features, and I didn't include a video on this because I'm going to talk about it right now, you want to be able to tell what the domain of a rational expression is. So what does that mean? The domain is all the numbers that you can plug into the rational expression, and it gives you back an answer. Okay, and you might go, yeah, isn't that like everything? Well, no, because remember the following. This is actually really important. I'm going to go over this because it's pretty critical in understanding how things work. Let's see. Let's go ahead and make these big. So we can see them better. Okay, so we have 2 fractions here. So we're just going to go back and remember what fractions are, because I know some of you are afraid of fractions, some of you don't like them, some of you think you're not good at them even though you actually are. I hear that from students all the time. Oh, I can't do fractions. Well, first they'll say, I'm good at math except when there's fractions. Like, there's always fractions. Like, if you're not good at fractions, then you're not good at math. But that's okay. You can get good at fractions. It just takes a little bit of effort. So fractions are going to come up constantly in this class, so it's another thing. You want to get comfortable with fractions, right? For college algebra, you need to be comfortable with them. But 0 plays a very interesting role in fractions. It does weird things. So let's go back to 3rd grade when fractions are first being introduced to you and you're first learning fractions, and we're like drawing fractions as cake or pizza or whatever you like. How do we interpret these 2 fractions? What do these 2 things mean? So remember, 0 over 3, that means I take my whole, right? Like a pizza, whatever it is. You take a whole pizza, and I'm going to cut it into 3 equal pieces. So it kind of looks like a peace sign, right? You've got your pizza with your 3 slices in it. So the 3 is telling us to divide our pizza into 3 slices, and the 0, that's telling us how many we ate. So I took a pizza, I cut it into 3 equal slices, and I ate 0 of them. So how much pizza did I eat? Well, it would be reasonable to say that I ate 0 pizzas, right? 0 pieces of pizza, however you want to say it. I think we can all agree that roughly translates to I ate 0 pizza. Okay, so 0 over 3 is totally allowable. It means 0 out of the 3 possibilities. Okay, what about this number here? 3 over 0, what does that mean? Well, break it down into your basic fraction definition and just try to explain it the same way we just explained that problem a second ago. All right, I've got my pizza in front of me. I'm now going to divide it into 0 equal pieces. What does that even mean? How do you divide something into 0 equal pieces? It's already one pizza. It's already one piece. How can I divide it into 0 pieces? That doesn't even make sense. But then on top of that, I've cut my pizza theoretically into 0 equal pieces, and I ate 3 of them? None of that makes any sense, right? Why? Because this doesn't make any sense. 3 over 0 does not make sense mathematically. Right? That's right. You've heard these terms before. We say 3 over 0 is undefined. And I remember asking my teacher in high school, like, what do you mean it's undefined? Why don't you just define it? Why don't you just pick a value, pick what it needs to be. When we say it's undefined, what we really mean is it doesn't make any sense. It's like if you walked into the classroom and I had a sentence written on the board with a start with a capital, I've got words, I end with a period, it'll look like a sentence, right? But when you look at it, you go, wait, those are just random words. That's not even really a sentence. It looks like a sentence, but it's not. It's the same thing here. This looks like something mathematical, but it isn't. It doesn't mean anything. It's just nonsense. It's like random words in a sentence. Okay? Why? Because we're trying to divide by 0. And you've probably heard this before. You can't divide by 0. And then some rebellious individual will say, well, I can do it. No, you can't. It doesn't make any sense. Again, back to when we say undefined, we mean it doesn't make any sense, right? If you have 6 things to divide amongst 2 people, then you divide 6 by 2 to get 3. Each person gets 3 things, right? So, or another way of thinking about it, if we put together 2 groups of 3, we get 6. Right? You turn that division down into a multiplication. What does it mean to divide something by 0? Right? Like, think about it the other way around. How many zeros can I add up until I get 6? That doesn't make any sense. You're never going to get there. It doesn't mean anything. There's no that's not a number, right? So the division by 0 just doesn't make sense. Long story short, you need to remember throughout this entire semester, 0 on the top of a fraction is perfectly legitimate. It just all translates to 0. So 0 over 3 really just simplifies to 0. Oh, I just put it on the wrong one. I can't believe that. That's what I meant to do. Ignore what's on your screen right now. Don't look at that. There we go. That's the right one. 0 over 3 is equal to 0. That's totally legitimate. You want to remember that. 3 over 0, undefined. In other words, makes no sense. Okay? It's important because this is going to be pivotal, especially when we deal with rational functions, which come up in this section, but they come up again. We're going to deal with rational expressions numerous times throughout this semester. Sometimes they'll just be in a section that doesn't even have to do with rational expressions, but some of your homeworks will have a rational expression in them while you're doing other things, so you have to know how to deal with those. So, when we have 0 in the bottom of a fraction, it makes it undefined. Well, that's pretty easy to spot when I give you a fraction like 3 over 0, right? But what if I give you a fraction, right? You might be wondering why I'm talking about all this. What if I give you a fraction like this, 4 over x minus 2? Is there a 0 in the bottom? And you say, well, no, there's an x minus 2 on the bottom. Okay, but what does x minus 2 evaluate to? And your answer should be, well, it depends what x is. That's correct. It depends what x is. What about when x is 2? Then we get 2 minus 2 on the bottom. And what does that mean we have on the bottom? 0. Oh, that's a problem. We just said we can't have that. So what you're trying to do is identify when is the bottom equal to 0. How do you do that? You literally set the bottom equal to 0. You literally take the bottom, x minus 2, set it equal to 0, and when you solve that, you get x equals 2, and that's the value that we exclude from the domain. So see how this example is called excluding numbers from the domain? That means we're kicking out the values that don't work. So here, you can't put 2 in this function because it'll give you 0 in the bottom. What about this one? What about x squared minus x over x squared minus 1? What can't go in the bottom? Well, 1 gives us 0. If we plug in 1 for x, we get 0 on the bottom. If I plug in negative 1 for x, I get 0 on the bottom. So there we have to exclude 2 values, 1 and negative 1. Oh, okay. Let's take a look at how do you do this in general then. What if I wanted to have, what if we wanted to know the domain for let's just make it x and then x squared minus minus 15x plus 63. No. 16. Okay, so if you're doing this problem where it says what should we exclude from the domain, well, for this problem where they're specifically talking about domain, all we care about is the denominator. Other problems you will care about the numerator, but for domain we just care about the denominator. So I look at this and I figure out, oh, what would make this 0? And it's hard to tell when you look at it, right? You go, I don't know, what, like those first couple were easy. If it's x minus 2 in the bottom, then it's obvious. Oh, x can't be equal to 2. But here you go, I don't know what x would be. So what you do is you literally just set it equal to 0. Because we're asking the question, when is x squared minus 16x plus 63 equal to 0? And then you solve this using the techniques that you just reviewed. So when we factor that, it's going to be what? X minus 9, x minus 7 equals 0. And then, then you'll get, you set your factors equal to 0, so that's going to give us x equals 9 and x equals 7. X equals 9. It should be 4. X equals 7. So now we have to be careful because if they asked what the domain was, we don't want to say 9 or 7. It's everything except 9 or 7. So you have to be careful about this question because they can ask it in a few different ways. They can say, what's the domain? They can say what should be excluded from the domain. They should say what values are undefined if we plug it into this problem. It's all the same math, but asked in a different way, right? So you just basically set the denominator equal to 0. That's the whole game right there. Okay. Let's see if there's anything else I need to mention. Oh, simplifying. You're just going to factor the top and bottom and cancel out common factors. So see how the factoring just keeps coming up again and again? Yeah, because it's going to. So multiplying rational expressions, I've got videos on those, so you should be good to go on multiplying those. Dividing. When you do a division, basically what you do, it's just like when you divide fractions. You take the second fraction and flip it, change it to multiplication. So if you understand the multiplication of rational expressions, the division's easy. It's just one extra step, and it's an easy step. Adding and subtracting, we got videos on those. videos for all of those on Canvas. Just double checking in case there's any little details that I wanted to point out. Yeah, okay, I think that's it. So that should bring us to, I think most of chapter 1, this is also largely review, but I almost think in some ways this stuff's not quite as bad, at least till you get to the absolute value inequalities. People struggle with that, but I don't have time right now to go over it. So see what you can do with it. But these other ones you should be pretty familiar with. For the other types of equations, I would say check the book for examples, because anything you have on the homework, there's going to be a very similar worked out example in the book. So pull up the ebook like I have, you know, and then you go, so you'd go what? You'd go chapter 1, other types of equations. And then you just look for the example in here that's like the one that you're looking at, and then try to make sense of what they did. Okay, that's how you're going to do that one. Complex numbers are actually pretty straightforward. There is videos for those. Quadratic equations, it's a number of different ways for solving quadratics. So there's basically, here's what you do when you have a quadratic equation you have to solve. You're going to try to solve it by factoring first, because that's the easy way. Most of the time it's going to work. If it doesn't work, because it may not be factorable, then use the quadratic formula. Okay. Along the way in that section you'll learn about completing the square. Completing the square is our step to get through the quadratic formula, but also we use completing the square for other stuff this semester. So it's important that you learn that method, even though it seems like, well, if I'm just going to use quadratic formula for solving all these quadratics, why do I need completing the square? And the answer is that we use it for conics, and is there something else? I'm trying to remember. It might just be conics. It might be something else where I feel like there's one other thing where we have to use completing the square. Okay. Linear equations and rational equations, pretty straightforward, and graphs and graphing utilities, pretty straightforward. Oh, that brings up another point. Let me show you. So Desmos, D-E-S-M-O-S, this is a free website. They call it a graphing calculator. It's not really a graphing calculator. It's more just a grapher is what they should call it. There's a couple calculation stuff in there, but I think they're stretching it by calling it a graphing calculator. But this website can be really helpful. In this class, we are very regularly going to be going back between graphing and algebra. Like we do this constantly. We look at the algebra and we figure out what does that tell us about the graph. We look at the graph and we figure out what does that tell us about the algebra. So you're constantly going back and forth between the algebra you have written on a piece of paper and the graph that you're going to visualize, right? Those of you who are going on to calculus, you do this all the time too. You're just constantly bouncing back and forth between graphs and functions and derivatives and graphs, and you're putting all this kind of stuff together. So Desmos, D-E-S-M-O-S, is a free, really good graphing utility. They call it a graphing calculator. I'd call it a graphing utility, but you can see, you can really quickly put in, x squared minus 3x plus 5. There we go. I got, just as fast as I could type it, it's graphing things for me. The way that you'll figure it out pretty quick. You use the caret, which is shift 6 on the keyboard, to get your exponent. So see if I do shift 6, see how it just put the value up in the exponent? I could put it like, a 3 on there. That's how that works. You'll learn the notation pretty quick. Plus they have a little, if you click this calculator looking thing at the bottom, right here, it'll bring up the tools where you can click your squares and stuff like that. But usually, it's easier to just learn the shortcuts, and then you don't even have to move your hands around. So always reaching for the mouse takes forever, right? You can just type it in here. So anyways, feel free to use Desmos. It's a really good graphing utility. Can be really helpful when you're trying to do a lot of problems and you're like, I kind of want to look at the graph of this, but you don't want to spend 15 minutes graphing it. Put it in a calculator or in the graphing utility, right? This is what you'll do in real life as well. Those of you who are going on to more, scientific-y, mathy type stuff, you're going to want to see the graphs of things. And no one really graphs things, unless they're real basic. People don't graph things by hand anymore because you saw how fast this graphing utility worked. And it's going to be more accurate than if I graph something by hand. So why not just use Desmos to graph it, right? So if I was taking this class, I would just bookmark Desmos, and maybe even when I'm doing the homework, just have a tab open with Desmos so that I can graph things really quickly when I wanted, when I'm working on the homework and stuff like that. Let's see, is there anything else I wanted to mention? It can be very helpful to have a graphing calculator in this class. If you were going to get one, I'd recommend the TI-84, but it's not required. You don't have to have it. You can kind of wait and see how it works out. Yeah. Okay, so I think that's about where we should stop for today. So as always, I'm going to shut down the YouTube stream. Anyone who wants to talk to me, feel free to hop over into Zoom, kind of get moving over there right now. And I can answer your questions for you, whether it was difficulty setting up the homework, or you don't understand something I've said today, or you have a question or a homework question or whatever. We can talk about whatever you want. I'll stick around as long as people are asking me questions. Otherwise, watch those due dates. Also, please be aware, do not wait till things are due to start doing the due date, because we move fast in this class. And if you wait till the due date to get stuff done, what you're going to realize is, oh, the next set of homework is due in a week, and oh my, there's a lot of it, right? So what I would recommend is stay ahead of the due dates. Get all this homework that's done. If you can, get it done ahead of time and start that next set of homework. Otherwise, what you're going to find is it's real stressful when you have these crunch times, and then you just aren't going to have the time to learn the material. So please don't have that mindset of waiting till due dates. Be ahead of the game. It's less stressful, and you're actually going to learn it a lot better. Okay? Okay, thanks everybody. I will see you on Tuesday. Meet me in Zoom if you have any questions. Thanks everybody.